The Channel Tunnel project, which is also known as the Chunnel, is an impressive engineering project of the modern age. The American Society of Civil Engineers calls it engineering magic. The construction of an underwater tunnel under the English Channel looked like a point from a sci-fi novel. History of the Chunnel project. The idea of a tunnel that connects France and England was discussed for centuries, but it wasn't until the 20th century that plans started to take shape. The proposal for the first concrete for the tunnel was made in 1802 by a French engineer named Albert Mathieu. He had a vision of a tunnel with carriages and an island in the middle for changing ventilation and horses. Shockingly, it wasn't constructing an oasis in North Sea waters, which made the project impossible. Political issues and national security concerns halted any project progress. Construction started in 1988 and was split into 3 sections: the tunnel under the English Channel, the 2 approach tunnels undersea, and the link between the national networks. More than 15,000 workers from each country worked continuously to complete the project. The construction was a challenging and complex process, with workers facing difficult terrain and harsh conditions. Despite difficult conditions, the project was delivered in just 6 years, with the tunnel opened for passengers in 1984. The completion of the project marked a great milestone in the transportation history of the region. It created a direct link between France and the UK that accounts for $138 billion in trade and transports $21 million passengers every year. The safety risks involved in building the tunnel was a difficult task, and it came with several safety risks that had to be managed carefully. One of the main challenges was the process of construction. Construction workers had to be handled carefully. Construction workers had to go through many geological formations, including clay and chalk, which posed a threat of collapse. Additionally, the tunnels were constructed at a depth of about 75 meters below sea level, which made it challenging for the workers to escape in emergency events. Fire safety was also a major risk. The tunnel had limited ventilation, which made it vulnerable to the rapid spread of fire. To mitigate this risk, a fire suppression and detection system was deployed at the tunnel. This system included smoke detectors, heat detectors, and water mist sprays of fire. Additionally, there were concerns about the workers' well-being. The process of construction required demanding labor and long hours, which increased the risk of injuries and accidents. To address these risks, safety protocols were deployed, including safety training and the use of protective equipment. Innovations in safety during the construction of the Channel. One big innovation was the use of boring machines. These machines helped excavate the tunnel and remove rock and soil while building the tunnel walls. TBMs also had safety features such as sensors for the detection of potential collapses and obstructions that ensured the safety of the workers who operated the machines. Additionally, the construction saw the deployment of regular inspections and safety protocols. Workers were trained in safety and were required to wear protective equipment. Regular response training and safety drills were conducted to ensure the workers were prepared. Water. Everywhere. During the tunnel construction, workers faced zones of chalk that were filled with water. This was a high risk as water could flood, putting workers in danger and halting the construction. To create a safe environment through these zones, the engineer used a ground freezing technique. Pipes were drilled in the section where water ingress was found. Liquid nitrogen was circulated through pipes, cooling the ground and freezing the chalk water. This created an impermeable and solid barrier of frozen ground, enabling workers to excavate the tunnel without facing the flooding risk. Fire safety in the tunnel. A fire detection system was deployed in the tunnel that consisted of smoke and heat detectors that were placed to identify signs of fire. In addition, water sprays were deployed to extinguish fires. Regular drills ensured that workers were prepared in an emergency. These drills enabled workers to excavate procedures and familiarize themselves with excavation routes and emergency exits in the tunnel. The role of technology during tunnel construction. Throughout the tunnel construction, technology was vital to ensure workers' safety and successful completion of the project. From state-of-the-art machinery to advanced monitoring systems, Advanced technologies were deployed to reduce risks and enhance safety. One of the main technologies used in the project was monitoring systems. These systems included sensors that monitored the integrity and alerted workers to potential obstructions and collapses. This data allowed for quick action to be taken to address safety concerns. Technology also played a key role in emergency response and communication. The tunnel was equipped with a communication system, including phones that were placed along the tunnel. This enabled the workers to alert the center in case of an emergency, ensuring a quick response. The tunnel stands as a testament to the power of technology in ensuring safety. The use of monitoring systems, fire detection systems, boring machines, and communication systems contributed to a safe environment and the successful delivery of the tunnel project. Emergency evacuation plans and procedures in the tunnel. The tunnel had emergency evacuation plans designed to ensure orderly and swift evacuation in case of emergencies. Every worker was trained on these procedures and plans to ensure that they were prepared for potential situations. The tunnel had an emergency communication system that enabled workers to alert the control center when faced with an emergency. The system included emergency phones placed in the tunnel, allowing workers to report incidents and call for help. The tunnel was split into sections to allow an organized exit in the event of excavation. Emergency exits and evacuation routes were easily accessible and marked. Regular exercises and drills were conducted to train workers in the process of evacuation and to ensure that they could efficiently and safely evacuate the tunnel. The Channel Tunnel, Eurotunnel, Project FAU. FAQs. What are some interesting facts about the tunnel? It is the world's deepest and longest railway tunnel that accommodates high-speed trains and reduces the passengers and freight travel time between southern and northern Europe and generates a host of environmental and safety benefits. What are the benefits of the tunnel? The tunnel allows London to be connected to Paris, Brussels, Lille, Cologne, and Amsterdam by train. Who built the tunnel? The tunnel was built by Anglo-French consortium Transmanche Link. The TML consisted of companies from France and the UK. What is the speed limit in the tunnel? Trains can operate at 160 km/h in the Channel Tunnel and 300 km/h in high-speed lines.